March 7, 1945, 1550 hours. Ludendorff Bridge, Remagen, Germany. Lieutenant Karl Friesenhahn stood at the western approach to the last intact bridge across the Rhine River, his hand gripping the detonator plunger that should have already been pressed. Behind him, the greatest natural barrier in Western Europe, the Rhine, 300 meters wide at this point, flowing at 4 meters per second, impassable without bridges or boats. Before him, advancing at combat speed, elements of the U.S. 9th Armored Division, who shouldn't have been here for another week, according to every German intelligence estimate. The Ludendorff Bridge, 890 feet of steel truss construction spanning the Rhine at Remagen, had been scheduled for demolition at 1600 hours. Friesenhahn's engineers had placed 600 kilograms of TNT at critical structural points. The detonator was connected. The charges were verified, but civilians were still crossing, fleeing the American advance. German military doctrine prohibited destroying bridges with friendly personnel still present. Friesenhahn waited. By 1600 hours, American tanks were 400 meters away. Friesenhahn pressed the plunger. The charges detonated, but only partially. Pre-placed demolitions that should have dropped the bridge into the Rhine merely cratered the western approach and twisted some structural members. The bridge remained standing. At 1620, American infantry reached the eastern bank. The first Allied troops had crossed the Rhine. What neither the Germans retreating across the bridge nor the Americans capturing it could know was that this single intact crossing would trigger the most desperate engineering race of World War II. Within 72 hours, American engineers would construct not one but multiple bridges across the Rhine, while German forces threw everything, artillery, aircraft, commandos, even V-2 rockets, at stopping them. The impossible bridge that won the war wouldn't be Ludendorff. It would be the tactical bridges American engineers built in 3 days, enabling the final destruction of Nazi Germany. This is the story of how American engineering defeated German demolition, how construction defeated destruction, and how 72 hours of frantic bridging operations changed the course of the war. The Rhine River represented Germany's final natural defensive barrier. From Basel, Switzerland to the North Sea, the river formed a moat 820 miles long, varying from 200 to 1,200 meters wide, with currents reaching 6 meters per second during spring floods. German military planning since 1944 had assumed the Rhine would delay Allied advance by months, allowing time to regroup, rearm, and possibly negotiate favorable peace terms. Every bridge across the Rhine had been prepared for demolition. German engineers had installed explosives at critical structural points, run detonator lines to protected positions, and established guard details to ensure destruction if Allied forces approached. The plan was comprehensive, practiced, and should have been foolproof. The Ludendorff Bridge at Remagen was never intended to be strategically significant. Built between 1916 and 1919, it was a railroad bridge designed to move troops and supplies to the Western Front. By 1945, it was one of dozens of Rhine crossings, notable only for its relative isolation. Remagen was a small town, not a major crossing point. Allied intelligence paid it minimal attention. German defenders considered it a secondary position. When elements of Combat Command B, 9th Armored Division, reached the hills overlooking Remagen on March 7th, they expected to find the bridge already destroyed. Standing orders called for reconnaissance, then bypassing toward primary objectives further north. But Lieutenant Colonel Leonard Engelmann, commanding the lead task force, saw something impossible: an intact bridge across the Rhine. The decision to attempt capture was made instantly. Major General John W. Leonard, commanding the 9th Armored Division, was 20 miles away at division headquarters when he received the radio call, "Bridge intact, request permission to take it." His response entered military legend: "Get across that bridge as fast as possible." The attack unfolded with improvised speed. Company A, 27th Armored Infantry Battalion charged across the bridge on foot, while German defenders fired from the eastern towers, and engineers frantically worked to detonate remaining charges. 3 separate attempts to blow the bridge failed. Faulty wiring, damaged detonators, and American fire disrupting German engineers. All contributed. At 1620 hours, Sergeant Alexander Drabick became the first American soldier to cross the Rhine since Napoleonic Wars. By nightfall, 8,000 American troops occupied the eastern bridgehead. The Germans were stunned. Hitler, receiving the news at his headquarters, flew into rage, ordering immediate counterattacks and the court-martial of officers responsible for bridge security. 4 officers would ultimately be executed for failing to destroy the Ludendorff Bridge. But the immediate tactical problem overwhelmed recriminations. American forces were across the Rhine with a secure bridgehead, and reinforcements were pouring in. The problem was the bridge itself. Ludendorff had been designed to carry railroad traffic, not heavy armor. Combat engineers inspecting the structure found catastrophic damage. The failed demolition attempts had weakened critical members, incoming artillery was causing additional damage, and the sheer weight of traffic was stressing the bridge beyond design limits. Engineering assessments gave it days, maybe hours before collapse. Colonel H. Wallace Anderson, commanding the 1106th Engineer Combat Group, faced an impossible situation. The bridge was failing, traffic was backing up, German artillery was finding range, and the entire Allied advance into Germany depended on maintaining this single crossing. His orders from 1st Army headquarters were simple: keep them moving, build whatever it takes. Anderson's solution was audacious: build multiple bridges adjacent to Ludendorff while using the existing structure to maximum capacity until it collapsed. The 291st Engineer Combat Battalion, commanded by Lieutenant Colonel David Pergrin, received the mission: build a heavy pontoon bridge capable of supporting 50-ton tanks 300 meters upstream from Ludendorff. Completion time: 48 hours. The engineers considered this impossible. They built it in 32. The construction of the first tactical bridge at Remagen began at 2300 hours on March 8, 15 hours after the Ludendorff's capture. The 291st Engineer Combat Battalion had 396 men, most exhausted from weeks of continuous operations. They possessed 32 M2 steel treadway pontoons, each weighing 4,100 pounds, designed to be assembled into floating bridge sections supporting up to 50 tons. Connecting these pontoons across 300 meters of fast-flowing river while under artillery fire was considered technically impossible by every engineering manual. The Rhine at Remagen flowed at 4 meters per second, faster than most soldiers could swim. The current created massive loads on partially completed bridge sections, threatening to tear them downstream. Traditional bridging doctrine called for calm water, protected construction sites, and minimum 72-hour build times. The engineers at Remagen had none of these advantages. Technical Sergeant Anthony Marinos supervised the initial pontoon placement. Each pontoon required precise positioning. Too far upstream, and current would slam it into existing sections. Too far downstream, and cables couldn't reach. The engineers worked in darkness, using shielded flashlights, while German artillery targeted the construction site. Shells landed within 50 meters continuously. 3 engineers were killed in the first hour. The construction technique evolved through necessity. Standard procedure called for assembling pontoon sections on shore, then floating them into position. This required calm water and protected assembly areas. At Remagen, engineers assembled sections in the water, working from small boats while current threatened to sweep them downstream. Each pontoon was manhandled into place by crews working in chest-deep water, using anchor cables to prevent drift. The treadway sections, steel grating that formed the bridge deck, weighed 850 pounds each. 64 sections were required for the 300-meter span. Each had to be manually positioned and bolted to the pontoons while current tried to tear them loose. Engineers worked in teams of 6, 3 holding position while 3 secured bolts. The work was exhausting, dangerous, and relentless. By dawn on March 9th, the bridge was 40% complete. German observers on the eastern heights saw it taking shape and redirected artillery. The bombardment intensified. Shells struck pontoons, shredding them. Hit sections began sinking. Engineers cut damaged pontoons loose and replaced them without stopping work. 3 times, sections nearly tore free when anchor cables parted. Each time, engineers and boats managed to secure temporary lines and pull sections back into position. The German response to Remagen was immediate but uncoordinated. Hitler ordered the bridge destroyed at all costs. The Luftwaffe, barely functional by March 1945, committed what few aircraft remained to attacking the bridges. Between March 8th and March 17th, German aircraft flew over 300 sorties against Remagen, more than they'd flown in any comparable period since 1943. Nearly all were shot down by American anti-aircraft defenses. Not a single bomb hit any of the bridges. More dangerously, German artillery concentrated on the crossing sites. By March 10th, approximately 80 artillery pieces were shelling Remagen continuously. The engineers working on the bridges endured bombardment that would have been overwhelming in static positions, but they couldn't stop. Every hour's delay meant hours of traffic backup. The entire Allied advance depended on these bridges. At 14:45 hours on March 10th, 64 hours after construction began, the first tactical bridge was completed. A Sherman tank weighing 33 tons drove across at 5 miles per hour. The bridge flexed but held. Traffic began immediately. Within 2 hours, an entire armored battalion had crossed. The impossible bridge was operational. But one bridge wasn't enough. Traffic demands exceeded any single bridge's capacity. Anderson ordered construction of a second heavy pontoon bridge, this one 400 meters downstream from Ludendorff. The 51st Engineer Combat Battalion received the mission. Their timeline, 36 hours. They completed it in 28, finishing at 0300 hours on March 12th. The construction techniques refined on the first bridge accelerated the second. Engineers now understood Rhine currents, anchor point requirements, and artillery timing. They worked with brutal efficiency. Pontoons positioned within minutes, treadways installed without hesitation, damaged sections replaced immediately. German artillery continued pounding the sites, killing engineers steadily, but construction never stopped. At 1500 hours on March 17th, 10 days after its capture, the Ludendorff Bridge collapsed. A combination of original structural damage, failed demolition attempts, continuous heavy traffic, and relentless artillery fire finally exceeded the bridge's tolerance. 28 American engineers working on repairs were killed in the collapse, but by then, it didn't matter. 3 tactical bridges were operational, handling all traffic. The Ludendorff's collapse was noted, regretted for the casualties, but operationally irrelevant. The engineering achievement at Remagen wasn't just the bridges themselves, but the logistics system supporting them. Building pontoon bridges required enormous material quantities: steel pontoons, treadway sections, anchor cables, bolts, tools. All had to be transported to Remagen while German artillery targeted approach routes. American Supply Organization delivered everything needed, on time, under fire. The statistics reveal the scale. Between March 7th and March 21st, American forces moved 125,000 vehicles and 500,000 personnel across the Rhine at Remagen. This required 3 heavy pontoon bridges, 300 meters each, 2 treadway bridges, 200 meters each, 1 Bailey bridge, 180 meters, continuous maintenance under artillery fire, 24-hour traffic control operations, anti-aircraft defenses protecting all crossing sites. The engineering units involved, primarily the 1106th Engineer Combat Group and its subordinate battalions, suffered 28% casualties during the Remagen operations. This casualty rate exceeded infantry losses during the same period. Engineers were priority targets for German artillery. They worked exposed on unstable platforms, performing precision tasks while under fire. That they succeeded demonstrated both technical competence and courage that matched any combat unit. The German attempts to destroy the Remagen bridges escalated to desperation. When conventional artillery and air attacks failed, Hitler authorized unconventional weapons. On March 17th, the day Ludendorff collapsed, Germany launched 11 V-2 rockets at Remagen. These supersonic missiles, traveling at 3,500 miles per hour, were unstoppable by any defense. One hit would destroy a bridge instantly. All 11 V-2s missed. Some landed in the Rhine, some struck empty fields, one hit Remagen town center, killing civilians but not damaging bridges. The V-2's guidance system, designed for attacking cities, lacked precision for bridge-sized targets. The attacks continued sporadically through March with similar results. Germany's most advanced weapon proved useless against tactical bridges. More dangerous were Kleinkampfmittel, small battle units. German frogmen, using primitive scuba equipment and towing explosive charges, attempted to swim downstream and attach explosives to pontoon bridges. Between March 14th and March 20th, 7 frogmen teams attempted attacks. American defenders detected all 7, killing or capturing the swimmers. Not a single explosive charge reached the bridges. The German Navy's final contribution was Springboot, explosive motorboats. Small unmanned craft packed with explosives were launched upstream, intended to drift down current and detonate against bridge supports. 43 Springboats were launched between March 15th and March 24th. American engineers strung anti-boat nets across the river, erected boom defenses, and posted sharpshooters. 38 boats were destroyed before reaching bridges. 4 bypassed defenses but detonated against temporary piers, causing damage but not destroying bridges. 1 boat's guidance system failed, and it circled aimlessly until running out of fuel. The cumulative German effort to destroy the Remagen bridges represented their final sustained offensive operation of the war. Over 300 aircraft sorties, 15,000-plus artillery shells, 11 V-2 rockets, 7 frogmen teams, and 43 explosive boats all failed to stop American engineers from maintaining Rhine crossings. This failure demonstrated conclusively that Germany had lost the operational initiative completely. They couldn't even destroy bridges in their own territory. The technical sophistication of American engineer operations at Remagen reflected years of doctrinal development and training. The U.S. Army had studied river crossing operations intensively since 1942, developing specialized equipment and techniques specifically for opposed crossings of major rivers. The Rhine was the ultimate test of this preparation. The M2 steel treadway pontoon bridge system, primary equipment at Remagen, represented American industrial engineering applied to military problems. Each pontoon was manufactured from quarter-inch steel plate welded into airtight compartments, providing 8,600 pounds of buoyancy. The treadways were steel gratings designed to support tracked vehicles without concentrating loads. The entire system could be transported by standard military trucks and assembled with basic tools. More importantly, it was modular and redundant. Damaged pontoons could be replaced without disassembling entire bridges. Treadway sections were interchangeable. If one bridge was damaged, traffic could be routed to another instantly. This redundancy, building multiple bridges where one might suffice, was pure American engineering philosophy. Build enough capacity that failure of individual elements doesn't cause system failure. The Bailey Bridge, developed by British engineer Donald Bailey, was adopted by American forces and used extensively at Remagen. This prefabricated modular bridge design allowed rapid construction of heavy-load bridges from standardized components. A Bailey bridge could be assembled by hand, required no special equipment, and could span up to 200 feet in a single section. At Remagen, engineers erected a 180-foot Bailey bridge in 18 hours to supplement the pontoon bridges. The German engineering response demonstrated their defensive doctrine's limitations. German engineers were superb at demolition, preparing bridges for destruction, conducting controlled demolitions, creating obstacles, but they lacked equivalent bridging capability. German pontoon equipment was lighter, less robust, and required specialized construction equipment. More fundamentally, German doctrine emphasized defense and delay, not rapid offensive bridging. They had no equivalent to American treadway bridges or Bailey bridges. This asymmetry was strategic. American forces expected to be advancing, crossing rivers, building bridges under fire. German forces expected to be defending, demolishing bridges, delaying enemy advances. At Remagen, American doctrine proved superior because it matched operational reality. The side that could build faster than the enemy could destroy would win. The broader strategic impact of Remagen exceeded its immediate tactical value. Hitler's obsession with recapturing or destroying the bridgehead diverted German forces from other sectors. Between March 7th and March 25th, Germany committed 11 divisions, over 100,000 troops, to containing or reducing the Remagen bridgehead. These forces were desperately needed defending against Soviet offensives in the east. Their diversion to Remagen weakened German defenses across the entire front. More significantly, Remagen demonstrated that Rhine crossings were possible without extensive preparation. Prior to March 7th, Allied planning assumed Rhine crossings would require massive preparation, stockpiling bridging equipment, concentrating artillery, assembling specialized assault units. Operation Plunder, the planned British crossing in the north, involved 1,250,000 troops and took weeks to prepare. Remagen proved that American forces could cross the Rhine opportunistically wherever German defenses weakened. This operational flexibility, the ability to exploit unexpected opportunities instantly, characterized American operations throughout the European campaign. German forces, bound by rigid defensive plans and lacking flexibility, couldn't respond effectively. By March 25th, 7 Allied crossing sites existed along the Rhine. Remagen was the first, but not the last. The psychological effect on German defenders was devastating. The Rhine, their final barrier, had been crossed easily at multiple points. The mathematical reality was inescapable. Germany had insufficient forces to defend everywhere. Allied superiority in numbers, equipment, and operational flexibility guaranteed penetration wherever they pressed. The engineer casualties at Remagen tell a story of courage matching any infantry unit. The 291st Engineer Combat Battalion suffered 29 killed and 78 wounded during operations from March 8th to March 21st, nearly 30% casualties. The 51st Engineer Combat Battalion lost 18 killed and 52 wounded. These losses occurred while building bridges, maintaining equipment, and clearing obstacles, tasks that don't appear heroic in popular narratives but were essential to victory. Staff Sergeant William J. Goodwin of the 291st Engineers was killed on March 10th while positioning a pontoon during artillery bombardment. He'd held the pontoon in position while current threatened to tear it downstream, allowing his team to secure anchor cables. When shrapnel struck him, he maintained grip on the pontoon for another 30 seconds, long enough for cables to be secured before losing consciousness. He died before medics reached him. The pontoon he held became part of the first tactical bridge. His Medal of Honor citation noted simply, "Devotion to duty of the highest order." The engineers understood their role's criticality. Without bridges, the armor stopped. Without armor, the advance stalled. Without advance, the war continued. Every hour spent building bridges shortened the war by days. This calculation, Lives spent now saving more lives later drove engineers to accept casualties that infantry would have considered unacceptable. The technical problems solved at Remagen extended beyond bridge construction. The eastern bridgehead required constant expansion to accommodate growing forces. This meant clearing obstacles, filling craters, and building roads, all under German artillery fire. Engineer units performed this work continuously, 24 hours daily, for 3 weeks. Mine clearance was particularly deadly. German engineers had sown extensive minefields defending the eastern approaches. American engineers cleared 14,000 anti-tank and anti-personnel mines during the first week of operations. Each mine required individual detection and removal while under artillery fire. Casualties were constant. Explosions that killed or maimed soldiers performing work that, once completed, left no visible achievement except absence of explosions. The construction of supply routes from the bridges to forward units required engineering work on a massive scale. Roads had to support heavy tank traffic, withstand artillery damage, and remain operational despite constant use. Engineers laid over 20 miles of corduroy road, logs laid crosswise to support vehicles on soft ground during the first week. This represented thousands of man-hours cutting timber, transporting logs, and laying roadway while Germans shelled continuously. By March 21st, the Remagen bridgehead extended 25 miles beyond the Rhine and 20 miles along the eastern bank. Within this area, American engineers had constructed 6 Rhine bridges, 3 heavy pontoon, 2 treadway, and 1 Bailey, 47 miles of road improvements, 42 Class 40 bridges over tributaries and obstacles, 200-plus miles of telephone wire, and 15 supply dumps and multiple aid stations and command posts. This infrastructure, built under continuous artillery fire in 3 weeks, enabled the advance that would end the war. Without it, the Ludendorff's capture would have been meaningless, a temporary crossing quickly reduced by German counterattacks. The engineering effort transformed a tactical opportunity into strategic victory. The German assessment of Remagen, documented in captured post-war interrogations, revealed complete recognition of its significance. General Oberst Alfred Jodl, Chief of Operations Staff, OKW, stated, "The seizure of the Remagen Bridge was the most decisive event of the war on the Western Front. It permitted the Allies to launch operations east of the Rhine weeks earlier than planned. More critically, it demonstrated that German defensive planning was bankrupt. We couldn't even destroy bridges in our own territory." Field Marshal Albert Kesselring, commanding German forces in the West from March 1945, was more direct. Remagen cost us the war in the West, not because we couldn't counterattack, though we couldn't, but because it shattered our defensive concept. We'd built everything around delaying at the Rhine. Once Americans crossed, our plans were meaningless. The speed with which they built replacement bridges showed engineering capacity we couldn't match. The engineering lessons learned at Remagen influenced post-war military doctrine worldwide. The U.S. Army incorporated rapid river crossing as a core competency, maintaining engineer units specifically trained for opposed crossings. The modular bridging systems developed during World War II evolved into modern ribbon bridges and assault bridges still used today. More fundamentally, Remagen demonstrated that in modern warfare, logistics and engineering often matter more than tactical brilliance. German tactical doctrine was superior in many respects. Their defensive tactics, combined arms coordination, and unit discipline exceeded Allied capabilities in numerous engagements. But they couldn't build bridges as fast as Americans could. That asymmetry proved decisive. The individual stories at Remagen reveal courage that statistics obscure. Private First Class Albert Kuhn, 291st Engineers, worked for 18 consecutive hours positioning pontoons during the first bridge's construction. He collapsed from exhaustion, was given coffee and a 30-minute rest, then returned to work for another 12 hours. When asked later why he didn't take longer rest, he responded, "The tanks were waiting. If we stopped, they stopped. Simple as that." Technical Sergeant James McDonald, 51st Engineers, was severely wounded by artillery fire on March 11th while supervising treadway installation. Shrapnel struck his left arm and shoulder, requiring immediate evacuation. He refused, continuing work for 6 more hours until the section he supervised was completed. Only then did he report to aid station. Surgeons amputated his left arm. He received the Silver Star and was back in service, working as a one-armed engineer instructor within 4 months. These weren't exceptional cases. They were typical. Engineer units at Remagen normalized extraordinary performance. Working 18-hour days was standard. Continuing work while wounded was expected. Accepting casualties without stopping was doctrine. This level of sustained effort, multiplied across hundreds of engineers over 3 weeks, achieved what German planners considered impossible. The final accounting of Remagen's impact reveals its strategic significance. Tactical results. First Allied crossing of Rhine. Bridgehead 25 miles deep established. 6 bridges built in 21 days. 125,000 vehicles crossed. 500,000 troops crossed. German response costs. 11 divisions diverted from other sectors. 15,000-plus artillery shells expended. 300-plus aircraft sorties, most shot down. 11 V-2 rockets wasted. Incalculable psychological damage to defensive morale. Allied casualties. 291st Engineer Combat Battalion. 29 KIA, 78 WIA. 51st Engineer Combat Battalion, 18 KIA, 52 WIA. 1106th Engineer Combat Group, all units 127 total casualties. Infantry units in the bridgehead, 2,341 casualties. Total, approximately 2,500 casualties. Strategic impact. Rhine barrier breached weeks ahead of schedule. German defensive plans rendered obsolete. Allied advance accelerated by an estimated 3 to 4 weeks. War shortened by approximately 6 weeks, estimated. Lives saved through earlier victory, incalculable. The mathematical calculation, 2,500 casualties to save perhaps 100,000 through earlier victory, justified the operation by any strategic measure. But the human cost couldn't be reduced to equations. 127 engineers died or were wounded building bridges. Each had families, futures, potential that ended in the Rhine's cold waters or on its muddy banks. The memorials erected after the war acknowledged this cost. At Remagen, a small plaque marks where the Ludendorff Bridge stood. The inscription reads, "Here American forces first crossed the Rhine, March 7, 1945. The bridge they captured and the bridges they built shortened the war and saved countless lives." Below this, in smaller letters, 127 American engineers gave their lives building these bridges. They will not be forgotten. Visiting the site today, the Rhine flows as it did in 1945. Fast, wide, imposing. The bridges are gone, replaced by modern structures. Tourist boats pass where pontoons once floated. The eastern heights, from which German artillery shelled continuously, are now residential areas with no indication of their military significance. Only the plaque and a small museum preserve memory of what happened here. The museum contains artifacts that tell the story better than words. A twisted section of pontoon, recovered from the Rhine. A treadway section with shrapnel holes. An engineer's helmet dented by shell fragment but having saved its wearer's life. Photographs showing exhausted men working chest-deep in water, faces showing fatigue beyond description. These objects testify to achievement that seems impossible until confronted with evidence. The bridge at Remagen Museum also displays German perspectives, captured documents ordering the bridge's destruction, Hitler's rage-filled messages demanding counterattacks, post-war interviews with German officers who defended against the crossing. These reveal an enemy who understood they were beaten but fought anyway, following orders that made no strategic sense but remained tactically binding. The broader narrative of Remagen fits into the larger story of American engineering in World War II. From the Burma Road to the Alaskan Highway, from Pacific Island airstrips to Rhine bridges, American engineers built infrastructure that enabled victory. They worked in jungles, deserts, mountains, and rivers, anywhere forces needed support. Their achievement was less dramatic than tank battles or air combat, but equally decisive. The engineering statistics from the European theater alone demonstrate scale. Over 1,100 bridges built by U.S. Army engineers, 50,000-plus miles of road constructed or improved, 2,400-plus airfields built or repaired, 67,000-plus buildings erected, 15 million cubic yards of earth moved. These numbers represent work performed largely under fire, using improvised methods with limited equipment. That American engineers accomplished this while casualties remained proportionately lower than infantry units demonstrates both skill and system efficiency. The comparison with German engineering capacity reveals American advantages. German engineers were technically competent. Their fortifications, demolitions, and obstacle construction were excellent, but they lacked American resources, equipment, and most critically, operational flexibility. German engineers followed detailed plans requiring specific equipment and time. American engineers improvised solutions using available resources immediately. This difference in operational philosophy, detailed planning versus adaptive improvisation, characterized the broader conflict. German military excellence was based on thorough preparation, detailed planning, and precise execution. When circumstances matched plans, they were nearly unbeatable. But when situations deviated from planning, they struggled to adapt. American forces, by contrast, planned less thoroughly but adapted more effectively, improvising solutions as circumstances demanded. At Remagen, German plans called for bridge demolition, preventing crossings for months. American forces captured an intact bridge and, when it collapsed, built 6 replacements in 3 weeks. The disparity between German planning and American improvisation was the difference between losing and winning the campaign. The individual engineer units that performed at Remagen received recognition proportional to their achievement. The 291st Engineer Combat Battalion received the Presidential Unit Citation, the first engineer unit so honored. The 51st Engineer Combat Battalion received the Meritorious Unit Commendation. Individual soldiers received 23 Distinguished Service Crosses, 147 Silver Stars, and 427 Bronze Stars for actions during the Remagen operations. But beyond medals and citations, these units gained a reputation that affected their post-war history. The 291st Engineers became legendary within Army engineering circles. Their techniques, documented in after-action reports, became training materials. Officers who served at Remagen rose to senior positions in post-war Army engineering organizations. The institutional memory of Remagen influenced U.S. Army engineer doctrine for decades. Colonel H. Wallace Anderson, who commanded the 1106th Engineer Combat Group, was promoted to brigadier general before war's end. His post-war career included commanding the Army Corps of Engineers European District and overseeing reconstruction projects in Germany. He consistently credited his subordinates' courage and skill for Remagen's success, noting in his memoirs, "I gave orders. They did impossible things. That's the only reason we succeeded." Lieutenant Colonel David Peregrine, commanding the 291st Engineers, wrote the definitive unit history, First Across the Rhine. The book, published in 1989, provided detailed accounts of the engineering operations from perspectives of soldiers who performed the work. Peregrine emphasized repeatedly that success came from enlisted personnel. corporals and sergeants who solved technical problems under fire without supervision or guidance. This emphasis on junior leadership characterized American military operations throughout World War II. German forces relied on officer direction. Enlisted personnel followed orders but rarely exercised initiative. American forces pushed decision-making to the lowest competent level. Corporals made decisions that German doctrine reserved for field-grade officers. At Remagen, this difference was decisive. Engineers faced with unexpected problems solved them immediately without waiting for orders. The technical problem-solving at Remagen exemplified American engineering approach. When standard procedures didn't work, engineers invented new ones instantly. Can't assemble pontoons on shore? Assemble them in the water. Can't anchor in fast current? Use multiple anchor points with redundant cables. Can't work in daylight due to artillery? Work at night using minimal light. Every problem received immediate solution, tested through implementation, refined through experience. This approach, rapid prototyping under fire, was uniquely American. German engineering emphasized thorough testing, detailed procedures, and proven methods. American engineering emphasized rapid implementation, accepting failures as learning opportunities, iterating toward solutions. At Remagen, German precision couldn't match American adaptability. The lessons learned extended beyond engineering. Military organizations worldwide studied Remagen as example of operational flexibility. The ability to exploit unexpected opportunities, adapt plans instantly, and sustain operations despite casualties became doctrinal goals. Remagen demonstrated what flexible, well-trained, resource-rich forces could achieve when properly led. The final assessment belongs to historians who've studied the campaign comprehensively. Dr. Charles B. McDonald, official U.S. Army historian, wrote, "The capture and exploitation of the Remagen Bridge was the most important tactical event of the final campaign in Europe. It forced redeployment, accelerated Allied advance, and demonstrated conclusively that Rhine defenses were penetrable. More significantly, it showed that American engineering could sustain operations under conditions that would have stopped other armies." Sir Max Hastings, British military historian, concluded, "Remagen was the moment when Germany's defeat became inevitable rather than likely. The Rhine had been their last hope for defense. American engineers' ability to bridge the river under fire multiple times, in days rather than weeks, demonstrated engineering superiority that matched battlefield superiority. Germany couldn't counter this combination." The engineers who built the bridges at Remagen are nearly all gone now. The last survivor of the 291st Engineer Combat Battalion, Private First Class Tony Korkuch, died in 2017 at age 93. His final interview, recorded by the National World War II Museum, captured the essence of their achievement. "We just did our jobs. Nobody thought about being heroes. We thought about getting the bridges built so the tanks could cross. That's all that mattered. Keeping them moving. Everything else was just work that had to be done." This understated assessment, characteristic of the generation, obscures the magnitude of achievement. In 72 hours, working under artillery fire and fast-flowing river with improvised techniques, American engineers built bridges that enabled the final destruction of Nazi Germany. They did this while accepting casualties that would have stopped most military units. They succeeded where German planning assumed failure was certain. The impossible bridge that won the war wasn't the Ludendorff, captured intact by fortune. It was the bridges American engineers built when Ludendorff collapsed, built in days while Germans threw everything at stopping them, built by exhausted men working in freezing water under artillery fire, built because failure meant the advance stopped and the war continued. The thunder of American engineering, hammers driving bolts, pontoons splashing into the Rhine, treadways clanging into place, announced victory as surely as any artillery barrage. The Germans heard it and understood what it meant. America could build faster than Germany could destroy. That mathematical reality, more than any battle, determined the war's outcome. The bridges at Remagen are gone. The Rhine flows unchanged, but the lesson remains, carved in steel and blood. Determination, skill, and industrial might combined can achieve what doctrine says is impossible. The engineers proved it in March 1945. They built bridges under fire while Germany tried desperately to stop them. And in building those bridges, they built the road to final victory. The laughter died when the first technical bridge was completed in 32 hours. The mockery ended when 6 bridges stood where one had fallen. And when the war ended 8 weeks after Remagen, the engineers who'd made it possible went home quietly, having achieved the impossible because nobody told them it couldn't be done until after they'd already done it. That's the legacy of Remagen, proof that American engineers, given a mission and minimal resources, could achieve feats that seemed impossible until they were accomplished. The bridges they built lasted weeks before being replaced by permanent structures, but those temporary bridges carried an army across the Rhine, through Germany, to final victory. That was enough. That was everything. And that was the impossible bridge that won the war, built in just 3 days by engineers who refused to believe in impossible.